Yeah, my name is William Wei. I have a long journey from a software perspective. I was trained in system software background. I used to work for Apple for 12 years before I came to Taiwan 3 years ago. And in Taiwan, I stepped into the new field called automotive, having a lot of fun. And after that, I found this the best compiler company in Taiwan, if it's not in the world, called SkyMiser. So I just recently joined them. Today, I want to share with everybody here about AI and in automotive, where my experience for the past 3 years with the recent AI trend. So when I was young, I entered this world called web. So web first. Everybody was in the browser, HTTP, all this. Everything is focused on building the web, from the infrastructure, from Cisco to the stack from the Amazon to the browser, right? And we spent like 10 years until we get into the, at that time it was the Apple, 2007, and then mobile first. Okay, so all the application moved to mobile. So everybody used the mobile in a way that is different from the web, the user experience, right? Now, today we have AI first. So everybody want to put the LLM not just in server, but today I saw a lot of Taiwanese company focus on put it on device. And not to mention this year, when Apple Watch and also Siri has what they call on-device Siri, which is on-device local inferencing, right? So everything is geared toward AI first. And we are in the juncture, the very beginning juncture for this journey. So from the perspective of the value we want to squeeze in, it's all about, in the human history, it's all about exchanging energy. Like we burn a lot of energy, we put a lot of effort, compress it for a value that we want. For example, blockchain, we a proof of work, we burn a lot of energy for blockchain. For what? For trust. Because we need this decentralized trust, right? And then for AI, for the past 6 years, everybody aware of ChatGPT. Everything burning is for what? For intelligence. Something you go in and come out with a task that it just finished to summarize everything, right? So you can kind of seeing all the trend. It's all about energy, right? So I need to start from not 20 years ago, but this past year, about generative pre-trained transformer, which is brought by OpenAI, ChatGPT, that brought the world attention. So we focus on this topic, we focus on model-centric ecosystem. See, RISC-V is all about building ecosystem, right? And then now, when you talk about model, not a lot of people talk about CNN nowadays, right? Everybody is talking about LLM, all this foundation model. But it's more general. Now, with this foundation model, our development, our software stack, turned into another paradigm of development. It's called fine-tuning or context learning. All this fine-tune, try to squeeze even more into this intelligence, right? And then want to put it on device. Like what Mr. Lian just now, scalable from the AIoT to the server, need to be scalable, but sort of LLM everywhere. And most important, if you want to put it on device, what it concerns is, what about your private data, right? You don't want to send all the data to OpenAI, ask them to train for you. You want to, for enterprise, you want to keep your enterprise secret on premises. If not on the edge, at least on your premises. So this domain data that nobody else have, you want to keep it. And last but not least is the security and privacy. So later on, we will talk about security a little bit and also privacy. How do we do that? So just now we mentioned inferencing, on-device inferencing. Today, we don't see a lot of on-device inferencing. Probably the latest Apple Watch, the chip they have on-device inferencing, series on-device, but I don't believe it's the end game yet because the user experience, it's not such a disrupted. Okay, we used to be living in a mobile-first world, like you flip your phone, you kind of search something, you want to do something, and then you do it yourself. But in the future, maybe if it's intelligent enough, it's all about task completion. You don't need to scroll around. So on-device inferencing is gonna. This is just my projection. I look through the internet trend and then see this on-server inference to the on-device inference to 2032. This is a trend that I'm observing. And then another thing is what I call public general training data to private data, even to the federated training, which on-device distributed, they can train together and get smarter every day, right? So this trend, I think, is gonna be kicked off by the community to explore all this solution to protect your data. So let's take this kind of a full life cycle of this training. You have genetic LLM, which is GPT, Llama 2, Cloud, Falcon, all this. It's trained on public internet data, right? We have this. It's already performing quite good. You can do summarization, all this, the killer feature, but it's limited. So from now on to the future, everybody start looking at, what if I use my domain data, right, to train? And you can train from scratch, which is very expensive, or you can train based out of the model size or foundation model you choose to train with, right? You in the future, you're going to have education domain GPT, climate GPT, right? Government, right? You can have city or government. 3 years ago, I moved back to Taiwan. There's a lot of government interface I have to go through, right? Visa, everything. And it's kind of spin my head, Googling everywhere, try to accomplish that. What if Taipei government is a Taipei GPT? You just chat to it, say, hey, I'm here. Help me go through all this a single window. In the future, each government have this chat GPT just solve all your problem, right? Automotive, where I spent past 3 years on. And then you have this domain-based, but still for personal, it's kind of generic LLM. Then you can fine-tune with your personalization, all the data. You fine-tune it, you make it smaller, you can put on your own device. Not necessarily your smartphone, although everybody, without any imagination, you say, oh, okay, I want to put it on my cell phone. But coming from Apple, I don't think my DNA tell me not going to be the same form factor of LLM on device. Maybe you have some kind of energy pack with you, and you have computation and intelligent core with you. And your user experience, your other application, not necessarily on your cell phone, right? So after you fine-tune all this private data on device, this require a lot of compiler technology while you're inferencing. How do you do with all this data to train become your own personal GPT, your city GPT, my car, right, GPT. So again, it can be Okay, all this can be, it can train private data from directly genetic. So software is getting fragmented. That's why recently you have Chris Lerner come up with modular AI, try to solve the software stack fragmentation problem. You have Ivy try to solve the backend compatibility problem. SkyMiser is in this game, by the way. So call for reunification. Software-defined chip is what everybody is talking about, using domain-specific purpose or application-specific purpose. But it's software-defined and software hardware co-design is different concept. Software hardware co-design is software give hardware some hint, and hardware give software design some feedback to co-design a ASIC, a special purpose future chip. Now you have AI SoC. Pretty soon you have LLM SoC, right? Hardware is, I will just skip this. All these domain-specific hardware. So RISC-V come to rescue, right? There's three. One is an open instruction set. It's customizable. It's royalty-free, right? Cost is insecure. Why is secure? Because it's open. Everybody can, just like Linux, everybody can expect it, see what's the bug. So at the end, it's going to be more robust. And low power and scalability. This, Testoran already have all this in the previous session. And then again, everybody here for vibrant community. This is what RISC-V need, a vibrant community to improve the rapid innovation, global standard collaboration. Right? So to recap, we coming from the general purpose computing, which everybody talk about flops, tops, right? All the CNN stuff. But now, if we use LLM-centric computing, then it's memory bound. This is for computer science, it's memory bound. It's all about how big the memory you can do. What's the bandwidth that you can ship all the data. So at the end, it's all about in-memory AI. This is one of the trend that I observe as far as the LLM. So first of all, move compute to data, right? How do you reduce data movement? And how do you increase the size and data bandwidth? And all this for the RISC community to ponder around. Automotive, the last. We know that this year, the 6 months of this year, in US, Tesla outsold everybody else combined, right? So Tesla is what everybody chase after. What is it about Tesla? It's all about software-defined vehicle. So what is software-defined vehicle, right? Tesla has FSD. It has a brain. A traditional automotive has no brain. It's just ECU, no brain. So if you are building a computer system with a brain, you got to put in OS, you got to put in real-time OS, RTOS. You got to build up the middleware, service layer, right? And then on top of the service layer, facing the community, you need SDK, you need API, you need the domain, EV, LLM, right? And then traditional application can come in, and the new application called AI agent, Copilot, can come in, right? So in order to build this, we need all this stack. Today, automotive has no such stack. Tesla has, but it's closed. So the gateway for other disruptive tech force to enter automotive is to build this and open it. To open it, what I call Android of EV. So 2 years ago, when I came back to Taiwan, I helped started the MIH, what they call Android of EV, the open platform for EV Kit SDK, 2020. And then everybody know Eclipse Foundation contact us at that time, and they started the software-defined vehicle working group in 2021, Eclipse. ARM approached us, say, hey, they're coming to launch what an open community for all the ARM instruction set. It's called SoC. So they started in September 2021. All this trend, and the last but not the least, the AutoWare Foundation started what they call Open Autonomous Driving Kit. And the last what I talk about is in the software, we see a trend to end-to-end, right? End-to-end meaning you don't code, you don't hand code anything. You don't understand how it get put it together, but it just works. So traditionally, we have this modular, deterministic world of modular design. Have a four-state machine that you fully understand, and you use code to glue together to become application. End-to-end, all the AI communities go into end-to-end. You input something, go through the model, compress all the intelligence in this model, and come out with task completion. In autonomous driving, mean drive safely. So autonomous driving, I put two examples. One is Waymo. They are modular plus code, glued together. Right? They have LiDAR, they have all the different sensor fusion. And for one community called Open Pilot and Tesla release 12 is end-to-end now. So here on the left side, you have multi-sensing. When you have multi-sensing, it gets really complicated. You got to do a sensor fusion. After sensor fusion, you pump through some CNN, many CNN to get a perception. You get object detection. And then you start coding some planning. How do you drive? How do you avoid? And then at the end, you drive, you control. So a lot of human code there. And then on the right is input vision data, model, and drive. On this map, there is Open Pilot's map. The latest map is a mimic human being. The model look at you feed model this navigation, and the model figure out how to control to go to the destination. So they don't even know how it drive, but it's end-to-end, it drive. So robotic, again, Boston Dynamic, modular, same thing, modular approach, and Tesla, end-to-end, right? There's some video. Let me just show one if you didn't. This is last week. They announced this last week, the latest model. So they only use vision. Even the joint control, they don't know how to control it, but the model learn how to control it. So you get the idea. For Boston Dynamics, it's really good too. I mean, it can do a special task. I don't know why internet doesn't play, but let's skip it. This is 1 year old anyway, Atlas. So new AI experience. It's different from deterministic application AI experience. Traditional application experience, like everything you install on your iPhone, everything it's information retrieval, and then you figure out what you want to do. But LLM, all this is fine-tuned. You just tell it what you want to be done, and it's done. It's called AI agent. This is new AI experience, right? So you can, for example, you can put the whisper, voice, and then you can have this open interpreter, and then you have this LLM, and the end of day is like Star Trek, right? That's Star Trek. That's end to end. New automotive experience. It's EVLM, and you fine tune it, and you become AI agent. This AI agent help you drive, help you open the window, whatever. You just talk to them. So this is voice, open interpreter. Open interpreter basically automated to compile a source code program for you dynamically and then complete. So if everybody old enough, everybody know the Knight Rider kit, right? This one, right? Bill. Well, you get the idea. So it goes through, with this brain, it goes through the CAN bus. CAN bus in automotive is a standard. It's a nerve system, it's a bus to pass around a lot of command to tell how to put on the torque. A lot of the ECU control use CAN bus to communicate. So with AI coming in, it will disrupt like from the distributed ECU. One car right now, modern car is about more than 100 ECU. It's all distributed. It's a dumb ECU, no brain. So software-defined vehicle with the CAN bus, it put this stack in with the brain. Then above, all the application developer can come in to innovate your new automotive experience. This is open interpreter. You can get online to see Hugging Face. Basically, this command is that, can you set my system to dark mode, my Macintosh, and then you figure out to set the dark mode. This is very interesting. This is I tell Bart, say, okay, this is my car is a Toyota 2022 RAV4 hybrid. So I tell Bart, say, go to internet and read all the thick manual, technical manual over there, and then help me accomplish some task. And I say, turn on the fog light, turn on the windshield wiper in the auto speed mode, turn on the FM radio, turn on the ADAS for highway driving, and then unfold my side mirror. And it go read the manual and shoot all the commands that need to accomplish those tasks. So in the future, automotive doesn't need to give you an owner's manual. You just talk to your car, say, what do you want to do? Just confirm it. So the race to build a software-defined vehicle, it's all about the brain. It's all about its AI SoC, so software there can stack up. And then, by the way, automotive world always talk about functional safety. So this is one of the implementation of architecture that satisfy ISO 26262 with a deterministic module handle safety, functional safety. Just like AI, you need alignment, you need guardrail, right? So this is a deterministic guardrail. It know all the safety functions. So when AI try to control this car, it will check and see if that you do it. Last is the commercial time, SkyMiser. SkyMiser is a software-defined AI SoC compiler company. One compiler for all architecture. That's their goal. So basically, SkyMiser defines software AI SoC architecture, and SkyMiser has an AI runtime engine to make on-device inferencing and training possible. It is optimized for state-of-the-art fine-tuned model and domain-specific AI application. We focus on production-grade AI model deployment on all ages with compiler-level acceleration software stack and tool. Thank you.